I will talk.
Okay.
But you certainly welcome to present yourself. Okay, so our next presenter is Val Huber. And people who are long time in this domain of business rules and different decisioning, they remember the very popular product called Versata. At least I knew it. And Val used to be a technical director, co-founder, and CTO of this company. And then this company went public, was with APO, with several billions dollars, so it was quite successful exit. And then Val co-founded another company, ExecutAble, with later acquired by Computer Associates. And so he is really highly experienced in business logic automation. And today, Val, as far as I know, running his own consulting firm, again in business rules and AI technology. So we will be glad to hear what your new endeavor is about.
Thanks, sir. Hello, everybody. Thanks for coming. So I'm going to be talking about mainly business rules, but covering other things as well, where the focus is going to be on governance by architecture, not discipline. Programmers are good folks, but they're somewhat like herding cats. Sooner or later, somebody's going to do something that you didn't really want. So we really want governance to be enforced by the architecture, not by the good graces of each and every developer. What that results in is a missing infrastructure layer for enterprise AI. So this is probably not a big surprise. AI is a very big deal, but AI success in the enterprise is not particularly common. Projects are not deploying. People are just not getting the results they want. And when you sort of peel it back, it's about integration and governance. So governance is kind of the problem we want to really be addressing. And that sort of challenge for AI is also reflected in what the CIOs care about. There's a source here that lists the top 10 concerns of CIOs, and governance appears in 6 of the top 10 considerations. And there's an underlying cause. If you're going to enforce governance with handwritten code, that's a pretty tough path. Further, it's not just about AI. We have a client engagement where a handwritten system is literally looking at an 8-figure exposure because a system they're doing is subject to regulation and audit, and they actually know that there's some missing issues in it that could be caught by an audit. So this notion of compliance verification of governance is something that deserves attention. More so now in the AI world because we can build things faster. This is a conference about rules. It took me quite some time to sort of peel apart in my own mind the different kinds of rules, because you can think you're talking about the same thing, but having wildly different understandings of what those things are. So here's the way I personally break it down. You may have different terms for these, but there's process logic. That's workflow between humans or computers, long-running transactions, people call it. We're in kind of the middle layer of transaction logic. That is when, and I mean this in the database sense, when a set of updates is applied to a database, governance must kick in to make sure that things are derived and validated in a proper way. That's as distinct from decision logic, which doesn't necessarily involve a transaction. You just may want to know the answer. All of these are actually potentially related. I think they're quite synergistic, and in my past, we have actually integrated all 3 of these together. Process logic may want to call transaction logic as one of the nodes in the diagram. And transaction logic may well want to call out to decision logic, for example, a decision tree to compute something. We're going to be focusing in this talk on transaction logic. So let's take an example. So this, for those of you who've not used it, this is VS Code, a very typical, very common IDE. And what we're doing here is asking AI to implement this set of requirements. It's a simple customers, orders, and items system. It's from an existing database. And what we are showing here is logic, as I think of it, multi-table derivations and constraints. So we give this in as a prompt. We could be a business analyst, a developer, a product manager. This is not a low-code orientation where there's screen painters and logic scripting. This is in a standard IDE, and you just want to basically plunk in this prompt to your AI and get a running system. And AI will do that. That's the experiment. It did happen. And let's focus. There's many aspects to the system. There's UI, there's API. I'm not going to talk too much about those. But I would like to focus on the logic because that's where the rules mostly fit in. So this is the logic, the code that came out from this. So from these 5 or 6 rules came 200 lines of code. That's quite a lot. So I looked at that code, and obviously the red suggests that it was not a pretty picture from my perspective. 200 lines of code from 5 rules is moving in the wrong direction. We had something here that was clear, and we muddled it. So I really don't want to read this code. That's particularly since I did read it and I found bugs in it. So that's a pretty bad combination. The code is not particularly readable, and we know that at least from time to time it has bugs. AI can make bugs. Can I maintain this? I prefer not to. I'm left asking, where are my rules? So what we think is a better approach is take that same logic, and remember the user is stating something here in actually very compressed terms. They're just talking about place order, but we want a system that it deals not just with place order, but deleting orders and updating orders and all that, number one. And number two, we want this. We want this natural language logic to turn into rules. And we want those rules to apply to every single transaction, to govern every single transaction that comes into that database, including insert and updating, deleting orders and items and customers and so forth. These I can read. This is actually the entire set of rules. It's 5 rules. Those rules, of course, don't run by themselves. So in addition to the rules, there's a transaction engine sitting back waiting on commit so that there's no bypass. So as a business user or an administrator, I can think this way. I can verify human in the loop that with logic, with rules I can read, and I can be sure that they're going to run because this rules engine, ideally, integrates with your ORM and takes action on commit. It basically is a commit listener. So that's kind of what we want. However, we want the AI that we used here, right? We don't want to lose the AI. We just want to sort of direct it. So how do we do that? Oh, I'm interrupting myself. So I'm offering a slightly more precise definition of what I mean by governance. It means I can read it. I don't want to lose the conciseness. I can trust it. I don't, there's no bypass, and I can maintain it. All these rules are going to be automatically ordered and reused by the rules engine, not by me. So how are we going to get out rules, not, if you pardon me, Frankencode, because that's not what we want. So the big trick is built into your project. One can provide what's called context engineering. Now this is, I'm going to delve for a moment into a little AI stuff. A typical way that people start, and in fact, the way I started this project, excuse me, get a drink of water here, is with prompt engineering, not context engineering, but prompt engineering. What that basically means is take this, the meat of the prompt here, and put bread around it of a whole bunch of context stuff that explains to AI what is the data model and what's the rules language and so forth. And that worked, but it was very unwieldy, very difficult to maintain. It was actually kind of slow. So what we've come to now is embedded in your project, used only at design time. This is a design or development time construct, not running at runtime, is this context engineering. There's gobs of it. It's like nearly 15,000 lines of this stuff. And what it basically does is we tell the AI, hey, look over here. This is your training. Your context engineering is training. And we paste in this same logic, this context engineering of which you're seeing an excerpt here. This is showing the syntax of a rule. Will now cause the AI, that same AI, to generate rules, not code. Okay? And these rules are deterministic. So we've just flipped from being kind of probabilistic, AI is going to interpret this stuff 99% of the time right, but there's all that 1%, that's a big number. Rules, the resultant rules coming out, we haven't run anything yet, this is design time, are completely deterministic, expressed in what often is called a domain systems language, a DSL. This is expressed in this particular case by Python, but these rules are readable. They may be not simple to write, but they're simple to read, and they come directly from these requirements. And it's these rules that are interpreted by this transaction rules engine that, as we saw, runs on commit. So that's kind of the bird's eye view of what's going on. As I said, there's APIs and UIs and so forth, but this is the focusing in on the logic. Now, as Jacob mentioned, I've got some experience with rules, and I think they're fantastic. I think they work. I think they've been proven in Versata and all those other companies, but I'm under no illusions that they're easy. They're not easy. It takes quite a long time to teach people to think in rules. And even this, maybe you're not thinking in rules, but you're thinking in requirements. This is still a rigor that's a little elusive to many people. They may be thinking of what they've done in the past, of procedural logic and the like. So one of the ways we used to encourage people to think in rules, in fact, we used to use this as a way, here's how to think of it so you can translate it into the rule language manually as opposed to using AI. We used to say, well, think of rules as it's just like a conversation that a business analyst would have with a business user. The business user might say, we need to check credit. And the business analyst would say, well, what does that mean? And the user would say, that means the balance is less than the credit limit. And the analyst would say, well, what's the balance? And the business user would say, it's the sum of the order amount, blah, 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 blah. So this sort of dialogue is a good way of eliciting rules. So we taught AI to do that. This is, in fact, that exact same dialogue. So we call this mechanism, in addition to sort of dumping the rules on AI's doorstep, you can tell AI, interview me. Just ask me and I'll answer your questions. So that's what you're seeing over here. This is the questions AI is asking, and this is me answering, in my usual sort of no extra typing model. So suddenly we've got an entirely different world here, which is instead of the burden on me to understand my requirements, I just have to answer AI's questions. And in so doing, I can do it. This is actually the same VS Code that we saw on this screen here. It's that VS Code now has a mode where it can go into sort of what I like to call is business user mode, taking away all the buttons and stuff that they don't need, so they can focus on their logic using AI. So that's a nice place to get to. So suddenly we have an interface that developers can use with all the bells and whistles, business users can use in this sort of simplified AI-focused environment. It's building from the requirements and then the rules into the same artifacts that are now visible to business users, business analysts, and developers. So suddenly, unlike low code, where you've got this sort of tension between shadow IT and IT, sort of now everybody's using the same tools, the same artifacts, and the same rules. That's a better place to be in our view. So if we take a step further, let's first look back. All the things I've talked about so far have to do with sort of design time generation. There's AI is being used at design time, not runtime. That gives us the opportunity to put a human in the loop. Are these the right rules? If not, fix them, and so forth. And that's what most people want. People don't want to compute the payroll from AI. That doesn't make any sense. In fact, it's a well-known internet meme these days. So we want deterministic logic for the vast majority of what we do in enterprise systems, but not always. One of the really powerful pieces of AI is it can do things that were simply not practical to do with writing code. So here's an example. This is that same customer orders and items system. This is the UI of it that you're looking at here. And what we want to do is, in addition to placing the order, we want to choose the right supplier based on things we can't predict, that we don't know when the application is written. So we want a new kind of rule. It's an opt-in. So I'm going to say use AI. This is my permission to use AI at runtime by finding the optimal product supplier based on cost, lead time, and world conditions. That's a pretty broad, set of requirements, right? And for that, we're going to have to call AI at runtime. Well, we don't want it to run amok. I mean, this is like opening the barn door. We don't want all the animals to run out. So we want a couple of things. Number one, if we pick a supplier for which we wind up buying $1 million wrench, we don't want that to happen. So the first piece is the rules still apply. The credit limit rule, for example, applies no matter how AI computes the supplier and the cost and so forth. Our deterministic business rules still apply. Otherwise we don't have governance. So AI can propose, but rules decide. Number one. And number two, we want to know what they decided and why. So what this screen is showing here is when the AI makes this decision, the system is architected so that an audit trail is written into the database that identifies the date and time this thing happened and what decision got made and why. This is saying, well, gee, the Suez Canal looks to be blocked. Therefore, we're not going to use the Cairo supplier. We'll use the ones in New Jersey, even though they're a little more expensive. So in other words, I know exactly what AI decisions have been made and why they made them. That's the audit part. So we can use AI logic. AI can propose things, rules decide, but we still get the auditing, which I think is a good place to be. So one of the nice things about having rules is that they're parsable. Our rules engine parses this, so can AI, so can your code, right? This is your stuff checked into Git and so forth. So that sets up some downstream value that you can provide by leveraging the rules. And I'm going to show you some examples. So when I've been working with this system, it's been my experience that writing the rules is easy, but we still have to test them. I mean, we believe the rules, but we trust but test. And writing those tests takes far, far, far longer than writing the rules. Far, far longer. I mean, weeks and weeks instead of 2 or 3 hours. No fun to boot. So I asked AI, can you generate tests for me? Here's some examples. AI likes to work from examples. And it generated some tests, and they were, the grade would be C minus, D plus. It was not that great. And then we had that kind of how about let's try this? Consider when you're generating the tests, use the rules there, and let that advise what test you're going to build. That was actually a very big insight because the rules are identifying all the fields that have implications to other fields, and that's the stuff we should test. So suddenly AI went from generating tests that weren't useful to now generating tests that are like this. I realize it's a little hard to read, but this is like Gherkin format tests. So that's a standard format. And all the backing code, thousands of lines of code here that actually run the tests. So now we have a nice test suite. Furthermore, if we run the test suite, the system can produce a markdown document that you can put on, GitHub or wherever, that identifies all the tests that got written and the scenarios and what rules actually fired on each test. What we've actually done here is wired up the rules engine to produce an audit log and then have the report tool take that log and figure out what rules fired and exactly how they fired. This is very hard to read, but this is showing the firing of each rule instance. So from each test, I can see which rules fired and exactly how they fired. So suddenly, we not only have test generation, but requirements traceability, which has always been something that people have wanted. This is a nice way of looking at rules. I think this is nicer. When I was at Versata, folks would take their swing, and every once in a while, a problem would come in like, I don't know how to do this. So what I would ask is, okay, tell me what you're trying to do, because you're new in the domain. And then what I would do is I'd sketch out the rules on a piece of paper superimposed on a database diagram. That's what this is. So this is a database diagram. These are one-to-many relationships faintly noted. That's not the important part because you kind of know that. The important part is these rules. So here we have the rules written on our diagram, and these lines represent the dependencies between rules, or think of it as the rule flow or the chaining, so that I can see when I insert an item, that makes this rule fire, that makes this rule fire, that computes this. So now you can see the chaining that happens implicitly with rules visually in a diagram. AI can produce can and does produce every single one of these. So you get these sort of governance reports, if you will, in addition to the rules themselves, which turns out to be very, very helpful. This is kind of a busy slide, but there's a very important message here. One of the folks I'm working with right now, in fact, I think he's listening in the audience, he and I have long since recognized that rules run at commit time are really a wonderful funnel to make sure that no matter what the source of the transaction, APIs, messages, a model context protocol, workflows, and so forth, it all comes down into this through the commit point, and the rules run based on that. That's a good thing. My colleague that I'm working with kept telling me something that it took me no less than a dozen times to finally hear, which is when he's worked with rules in the past, by necessity, rules also, a rule engine should also accommodate procedural code to do whatever is not automatable from rules. There's always something. It's not hugely a large amount, but it's very important. You can't solve 98% of a problem. So there has to be a procedural escape. And all too often, the developers would run home to code. And then, of course, you didn't have the governance you wanted because governing procedural code we know that's a hard problem. So the solution here is, in addition to this runtime funnel, to have a design funnel, which you can state your requirements in any number of formats. You can literally point the system to regulations, and I'll show you an example in a second. You can provide Gherkin format, pseudocode format, whatever you want, natural language. Whatever you provide, it turns into rules, and those rules are operating on the commit funnel, governing all these transactions. So what my colleagues calls this is governance at scale. That is, this is across all transactions. This is really meaning across all the developers and their projects. And that's a very big deal to him. And I finally, after he explained it a dozen times, understand and appreciate it. I don't have a diagram or demo for this unless you really want one. But I want to make clear that rules they're a thing. but they don't run sort of in isolation. So the same AI that can generate rules can and does generate the other enterprise infrastructure to support messaging, APIs, including MCP discoverable APIs that enables the MCP agents, AI-Logic, which we saw earlier, roles-based access control, so people have proper filtering of the roles that they're allowed to see. And Philippe mentioned earlier that we love models. Even more than I love models, I love executable models. So all these specifications are generated as models as part of that visual code project, I beg your pardon, that you saw earlier. And you can run it and debug it and use your standard tools to do that. So where does this all lead? We've been developing the system for quite some time. And as these, what we call these executable requirements have come on board, I've been running them with the colleague I was just referring to and projects I've known in my past. So let me start off at the bottom. I happen to be from Kentucky, and I did a sales call in Kentucky several years ago. And I'm going to explain this system. It's pretty complicated. All you really need to do is get the sense of how complicated it is, but let me explain it. So is a state government, and they have projects, and they want projects to be funded by multiple departments. So they want to have an agreement that says this department will fund 30%, this department will fund 40%, and so forth. That's an agreement. Then a project is commissioned with an agreement so that when charges come in, they're funneled to those departments according to the agreement. Furthermore, once inside a department, those charges are funneled to that department's general ledger accounts and another set of definitions. That entire system, that's a large system. That's a non-trivial system. When I rolled into Kentucky, 4 developers had been working on this for 2 years, literally. This entire system is now generated as one English language prompt. It's not a simple prompt that took me like a day to do it, but we're literally comparing sort of 8 person years of effort to a day of work. And we're talking about a complete system. This is a system, this prompt builds the database, the rules, a back office UI, the API. The API is MCP enabled. That's a complete project done in a day. When I saw this run, I was affected. The fellow in the audience, and I will not mention his company's name so that he can continue working at that company, built 2 systems. One is this 8-figure compliance system. This is a system where shipments come in and they have to be classified so that customs can be sure that people aren't shipping in firearms or drugs and stuff like that. Those systems have to be audited. And that's the audit that failed. What he did is he went to the Gherkin requirements they had and fed them into AI, and it built the system and caught the error that the hand code had missed. In addition, this was a 1-day project, maybe it was 2 days, something like that, versus months of effort for a team. So they're pretty excited about that. I'll show you in the next slide or two another example they ran, which is when customs come in, they have to price how much the customs is. And here, the gentleman gave a prompt, and that prompt actually identified the regulations, and the system processed the prompt, noticed that there were regulations in the prompt, went out to the internet, read the regulations, and generated, again, a full system, the rules, the database, the API, and a UI. So those are the kind of results we're getting with this sort of AI plus rules architecture today. And here is the exact prompt I just referred to. So this was his first try. And I'm not a custom expert, and probably you aren't either, but this is the entire prompt. it generated these rules, which, I barely read. I depend on him knowing what the right answer is. And it generated this rules diagram, as we saw earlier. It's in this, these are the regulations that are being referenced from this prompt. And the system is literally not just generating software from this, but also from the regulations that are referenced. I think that's pretty amazing. I'm done. So I have some other slides in case you have questions, but I thought this would be a good time to pause for questions. So, Jacob?
Okay, thank you very much. It is impressive. Some of
Thanks,
us
sir.
experience it. It is very impressive.
Thank
And
you.
I'm sure you will get a lot of questions.
Why don't you start?
Anybody? I don't want to dominate these questions. Anybody questions? So, okay, I will ask you about how you can reconcile your knowledge of complexity of rules and that it's majority of problems usually connected in regular rules with exceptions, right?
Right.
98% simple, but 2% take 90% of time. And now, when you don't want, you said you don't want to look at generated rules, you just can test them. How, what's the level of trust you have to the generated rules?
Several levels. First, I always look at the rules when they get generated. So that's one of the values of generating rules is there's suddenly a rigorous reformulation of the natural language requirement. And as we showed earlier, the fact that the software the rules were generated by AI does not absolve the system from having tests that verify that they work. So tests in any format we use that Gherkin format. There's packages in Python that support that, so that's what we used. But so there's human in the loop to read the rules, and then there's the tests. In terms of dealing with the exceptions, the things you also asked, how do we deal with things that aren't rules? It's a Python system, so you can do whatever you want. You can add your own custom APIs. You can add your own custom messages, listener, all that stuff. But whatever you do in your custom code is still going through the ORM, the Object Relational Manager, which in the case of Python is SQL Alchemy, and that's where the rules run. So whatever you do, the rules are still kind of snooping on you. And finally, you asked about the exceptions. One of the rule types is sort of semi-procedural. It's an event rule. So, when this condition is true, run this bunch of code. That bunch of code is also subject to rules. So it's going to go through the same sort of commit logic, but you can do that as well. Did I answer your question? Thank you.
Partially, but let other people to ask questions. Anybody? Okay, people probably a bit tired, like most of us.
Well,
Uh,
I've put audiences to sleep before. It's
no.
in the skill set.
No, you said a lot of controversial thing, I would say, about this. So you basically you switch from one camp to another camp recently, right? You trust generation of decision models, automatic generation of decision models. You have some probably how you better call them guards, or you support prompting technology, but
Yeah.
you really trust that you can put these rules in production.
Yes, subject to what I said earlier. I expect people to read the rules that get generated and have the usual testing around them. But yes, I do. Yeah.
Okay, that's
One of the what there's if we have a moment, maybe there's something that people will find interesting.
yeah.
So I'll give you a glimpse of this context engineering because I think that's a little bit mysterious to a lot of people, if I can find it.
Mm-hmm.
So here's all the training that's baked into your project. Now this is training for AI. This is not used at runtime. This is training for AI to generate the rules. So for example, here's the Logic Bank API, the rules to say, I can't find one. There's one at the top. Here's the syntax for a sum rule. So this stuff here is what the AI uses to generate rules, not code. And what's beautiful about it is that I can now state my prompt down here, and AI is wired, if you will, to read all this context engineering and use that to generate rules and messages and reports and all that other stuff. So this is the stuff there's nearly 15,000 lines of. Now, Jacob, to your point, the way this got built, sort of many aspects of this, but a fairly interesting one is I would build a system and I'd test it and I'd say, oh, that's not right. So then I started training AI very much like you train a dog, which is kind of a humorous way of putting it. I'd say, look what you did here. This didn't work. See this bug? Please update your training so you don't make this bug the next time. So AI would look at the bug, figure out why it failed, and update its training, and then we'd repeat the test. Generate the system again, look at the next bug. And then pretty soon, it not only knew how to generate the rules, but generate them without the kind of bugs that happen on first blush.
Okay.
And what I found is after that training, the kinds of prompts that I showed you earlier, that customs, we didn't really find many errors in the rules generation. It was a pretty remarkable process because we sort of figured out how to have AI train itself so that subsequent generations had benefit of the earlier errors.
And when you have these rules already tuned, generated, and your LLM or AI assistant already trained, you put this in regular secure repository in
Yeah,
GitHub, and you putting this in production. And what happens 3 days later or 5 days later when you want to make changes in these rules? What you actually do?
that's a very good question. When we generate the rules, we save your prompts.
Mhm.
That's not a very good one. So you can come into AI and say, revise the check credit requirements so that the balance is less than or equal to the credit limit.
Okay.
And AI will figure out what rules came from this requirement and fix the generated logic. Now, again, I keep pointing out, I think it's critical that at all times, I trust the AI, but only so far. So notice that my use cases show up as sort of artifacts here, and these are my rules. So these rules, I can put breakpoints on them, I can read them, they're audited, they produce audit logs, all the things that programmers expect of their own code and often don't build are sort of built into this.
Okay, let me clarify just one thing. We have another question. But so when you want to make changes in your decision model already generated a week ago, you feed only previous prompts and modify prompts. You don't feed
Yeah.
your LLM with already generated rules. It has no idea about what was generated, and maybe you manually added these rules, or you never.
No, it does. It does know what's generated. There's a report someplace that tells it what generated, what requirements came in and what rules came out. So it knows that. So it's an iterative process. I don't just rebuild the system. I come here and I do what I just said. I said, change the check credit requirement so that the balance is less than or equal. And the system will figure out the things that are not that easy to trace down the generated rules from the generated logic and fix them.
We
So
do
very
have
much
we do have question, another related question. You can
sure.
Somebody who does it matter what LLM tool you use to run the prompt, and how do you design system so it generates the same answer every time?
It doesn't matter what LLM you use. Let me rephrase that. It does matter what LLM you use, but you can use any one you want. This training that we looked at, here we are. Have you noticed that your IQ goes down by 100 points as soon as you're doing something in public?
That's okay.
So this training that you're looking at, that's a markdown document. So unlike the prompt engineering where you're calling an API of OpenAI or whoever, you're not doing that with context engineering. So that's the distinction. With prompt engineering, you're speaking to a particular LLM. With context engineering, you can say here what LLM I want to use. So I've tried it with Gemini, I've tried it with OpenAI, I've tried it. We get the best results with Claude, but that's just us. But you're free to use whatever you like.
Okay, Richard, you can ask your question. Unmute yourself. Okay, you.
Sorry, I just put a comment in. I found this talk very, very helpful, really helpful. And I would like, I'm sorry, I came in late on this particular presentation and I will rewatch it. But this makes a lot of sense to me. And it feels like something that might be going on in GitHub Spec Kit to a certain degree, but you have less control over it there. So I found this, yeah, inspiring. I guess I need more time to dwell, but.
Well, thank you very much. If you want to look at it, it's open source. You can download it, and even my best friends would prefer not to download my software because they're always afraid something's going to go wrong. So one of the things that we provided, there's a wonderful technology that GitHub provides. So this project is a GitHub project. You can stick it in GitHub and off you go.
Okay.
But GitHub also provides a whole other technology called code spaces. Let me touch on that just a moment because that's very interesting. When I first heard of this, I thought, you're kidding me. That can't possibly work. So what code spaces says is, give me a project and I'll run it in code spaces, meaning GitHub will literally requisition a computer in the cloud, install Python and our stuff on it and your project, start up VS Code and give you a link to it in your browser. So suddenly you're running VS Code in your browser on this remote computer that CodeSpace is set up for you. It's astonishing. And the business objective behind CodeSpace, as I understand it, is that a team of developers suddenly can share the same underlying configuration without having everybody install the right versions of the right stuff. And I'm sure that's true. I think that's a brilliant idea. What I've used it for is a demo. So if you'd like to fiddle with this software off of our homepage, you can start up code spaces and build this project.
I will. Yes, definitely.
So
okay, well, you would after this you can paste your links where people can download this on the chat. Okay.
Fine.
Okay. If you don't have any more questions, thank you very much. It was really enlightening to see how a person who spent his life in regular business rules, traditional rules-based development, switching right now to new tools, because I hear frequently from younger people, if you're after 50, you cannot do anything else. So it's apparently
well
not
after
true.
50.
So it's so hopefully there is, like Philip said, foundational knowledge still very important, and if you add the modern AI capability to this, you can get amazing results. Thank you very much, Val.
Thank you, Jacob. And I just want to, as a last comment, sorry, I think you're exactly right. I think the idea of AI plus rules in the right blend is a remarkable result. So there's not either or. Thank you very much.
And not only I would add the rules, but also constrained linear solvers plus machine learning algorithms and even BPM tools, very, very important. And we will hear more about this during these 4 days. Thank you.
Thank you.
Okay.